I was recently clearing out some old things and I came across my old stereo. It's got a combined CD player and radio, the radio being completely analog. Have a little look inside and see what physics we can find. Once we open up, we're going to keep track of several different physics related components that we might find. Now for each of these categories, can we have a little guess of how many of each we expect to find in there, and then at the end we'll compare that and see how well we did. A little look inside our circuit board here, lots and lots of resistors and capacitors. So I'm going to have to count them in a minute. Standard plug connected to the transformer. So this transformer, very helpfully, gives us a little bit of information about it. It's expecting that mains voltage of 230 volts. It has an output of 11 volts. We've got this iron core, which is used to enhance the magnetic field. Rather than having just a single piece of iron, we can quite clearly see that it is made of many, many pieces of iron. Each of those pieces is laminated, and this prevents those eddy currents from forming that would waste a lot of the power. We've got our two coils of wire, and because this is a step down transformer, we need to be having more coils of wire on the primary coil than on the secondary coil. Now I was hoping I could actually take this apart and count it, but it turns out to be a bit more rugged than I'd expected. If we have a little look, we can see on the primary coil we have lots and lots of loops around it with this very thin wire. On the secondary coil, they've actually used a slightly thicker wire, but there are far, far fewer loops, which is how we get that big reduction from 230 volts all the way down to 11. We've got the CD player. We've got a spring, which is what is providing that force to open it. But it's also moving a lot slower than the spring would on its own. And that's because of the gearing system. Now we've got this sort of smaller gear and the bigger ones. We've got a little warning sticker there. This is where the laser is. The CD reflects the light of the laser, sort of patterns of ones or zeros that the CD player can then decode into the music. We've got the two motors. One of them spins the CD round, which is how it continues along the progress of the song. And we've also got this second motor, which is connected to this gearing system. And this slowly moves the laser from the centre of the disc out towards the edge, and so the whole of the CD can be read. So the motors should have a magnet and a coil of wire in there. Those are pretty well sealed in. After a little bit of gentle work with our hammer, we've got this ring, and that ring is a magnet. At this stage there's more than one in there, but we're just going to count it as one, because in the working radio that wouldn't have been smashed into little bits, and obviously it's going to be exactly the same in this other one. Actually got 3 little coils of wire, so each of these will have current running through it, which will of course generate its own little magnetic field, which will push against the permanent magnetic field, causing it to spin. So we've got some of the radio stuff here. The antenna, and this is what picks up the radio waves. Radio waves are part of the electromagnetic spectrum. As those waves are oscillating, they contain perpendicular oscillations in electric and magnetic fields, and the aerial, or at least this aerial, is picking up the electric part of that oscillation. They cause the electrons inside this antenna to oscillate, which is what sends a signal. This antenna is used for the FM part of the spectrum, which is typically around 100 megahertz. And as a general rule, this sort of antenna needs to be around half the wavelength of the wave that it's picking up. That's obviously not exact, this is picking up quite a range of wavelengths. The AM frequencies are typically in the thousands of kilohertz, so a much lower frequency and therefore a much longer wavelength. To be about half the length of the wavelength, it would have to be enormous. Instead, rather than picking up the electric component of our electromagnetic wave, the AM frequencies are picked up using the magnetic component. The second aerial is this. Because of the oscillations of the magnetic field, is going to then therefore generate an alternating current that is going to match up with that and can be used to pick up that radio signal. Now again, this is going to be picking up a whole range. So in order to listen to a particular station, you would have to select a certain one of those frequencies. We've got this knob that we use to find it. Now when that moves on the front, it moves this little pointer, which is what shows the station, the frequency. And then this gear is connected to a variable capacitor. With a capacitor, it takes a certain amount of time to charge rather than having an instantaneous current going through it, and then it also takes a while to discharge. Whenever your aerial is producing a series of waves, it will only be able to really respond to the ones that match up with the speed of the slope of the capacitor. It will select out for waves of that particular frequency. If you just have a fixed capacitor, that is only going to work for one frequency. So instead they use the variable capacitors. Turning it more sort of slides these plates over each other, and you can see between each layer of plates we've got that dielectric which increases the relative permittivity between them. Alternate layers of different shapes sort of rotated around, increasing that surface area between them, increasing the capacitance, and therefore changing that resonant point where it's selecting out the frequencies that match up with the radio station that you wanted to listen to. Okay, we've got one more circuit board. This is all the bits that are connected to these buttons. We've got the LCD screen, switches, we've got an integrated chip there, and an LED. And lastly, we have the speaker. I think I might have to see if I can crack my way in. Okay, I think we're going to have to go in through the front. But, there we go. So this cone, actually, you can see, is basically just paper. Okay. So we've got these two wires that are going into this part that were coming with that oscillating signal being sent through this coil of wire. Definitely got a magnet in there. And so it's that relationship between the magnetic field that we are generating through that coil of wire and the magnet that is causing those vibrations. So, I think that's all of the major physics-related features of our radio. All that's left to do now is to count up all of the components. Okay. How did you do? Was there more than you expected? Less? Almost all the ideas that we learn in physics have got some practical applications, and I hope today helped put a few of those into context for you. Thanks for watching and have a great day.